This is GATE 2017 set 2 EC question number 53. It says an electron Q1 is moving in free space with velocity 10 to the power 5 meter per second towards a stationary electron Q2 far away. The closest distance that is this moving electron gets to the stationary electron before the repulsive force diverts its path. So all the values are given. Mass of electron 9.1110 to the power minus 31 kg, electron charge minus 1.625 10 to the power minus 19, and permittivity 1 by 36 by 10 to the power minus 9 farad per meter. So let's see what is being said in this question and what information we actually need in order to solve this question. So two charges are there. For example, this is charge Q1, this is charge Q2, and these are electrons. So now this electron is moving with a velocity 10 to the power 5 meter per second, and this one is stationary. Now what is said? So because of this velocity, and the force will always act in this direction, if electrostatic force, but since this velocity in this direction, it will continue to move in this direction. But in the question it is asked that how much distance maximum it can travel before which its path is being redirected due to the repulsive force Fe that is acting on this electron Q1 due to this stationary electron. So maximum distance, think it like a spring. So maximum distance, you can push this part up to this maximum, let's say that is the maximum potential point. Maximum potential point up to which you can compress this spring, after which its path will be reverted. That is, it will be moving in the opposite direction, that is due to the repulsive force that will come into action. But at the initial stage it has a velocity very high, 10 to the power 5 meter per second, due to which it will continue to move in this direction up to this point, that is maximum potential point. You understand this because this force is continuously acting and will be increasing as closer as it moves towards this charge. So this velocity will also decrease, and once at a time it will become 0, and at that point is the maximum potential point where its velocity will become 0, and the Ke to Pe conversion will happen. Ke to Pe, that is kinetic energy, will be converted totally into the potential energy, which is given by if distance is r, which is given by Q1 Q2 by 4 pi epsilon naught r. This is the distance and this is the potential. So potential max, this is possible before redirection or before path change. Now this is the potential energy. So all this kinetic energy will be exhausted and converted to potential energy. So this must be equal to kinetic energy, which is half mv squared. So mass of electron and velocity of electron at the initial stage is v is 0. Let's name it v is 0, which is this. So just balancing the energy, we can find out this distance r, which is being asked in the question, such that maximum path it can travel and the distance at that point between these 2 points, after which it will be redirected in the opposite direction due to the repulsive force coming into action, which was also into action before also, but due to the velocity it continued to move in the same direction and it was decreasing, the velocity was decreasing due to the force, but it was continuing in the same direction. But at this point when it becomes 0 velocity due to this force, after that it will move in the opposite direction. So this point to this point distance is being asked, right? Now one thing to note, it is stationary, right? It is maintained stationary because this force also will act due to this, but it is maintained somehow at stationary condition. So now you see the energy balance is the key to solve this question. So half into mass of electron, which is given, into velocity of electron at initial stage is given. This is the initial kinetic energy we are talking about, and whole of this will be converted to the potential energy maximum when its velocity will be 0, and the potential is given by Q1 Q2, that is charge of electron 1 and 2, which is same. So we can write that later, and divided by 4 pi epsilon naught into distance, which is the potential. And this point the kinetic energy is 0, so maximum potential, right? You understand? And now half into mass of electron is given by 9.11 into 10 to the power minus 31 kg. 9.11 into 10 to the power minus 31 kg into 10 to the power 5 whole square, right, equal to 1.625 into 10 to the power minus 19, which is the charge of the electron. So minus 1.625 minus 1.6 you can take, because in the question it is given minus 1.6. So minus whole square is, so it is plus. So this whole square divided by 4 pi epsilon naught into 4 pi into epsilon naught. Epsilon naught is 1 by 36 pi 10 to the power minus 9. So 1 by 36 pi and then 10 to the power minus 9 into r, which is being asked in the question. 5.0 r is coming around 5.05 into 10 to the power minus 8 meter. So this is the answer, 5.05 into 10 to the power 8 minus 8 meter. So this is the answer.